My name is John Griffith. I work at Solidfire. I'm a lead open source developer there. I've been there for 3.5 years. Our founder, Dave Wright, came from Rackspace, was looking to solve block storage problems there. Couldn't find anything that did it, so he actually left and started his own idea and invented Solidfire. I want to talk a little bit about Cinder, what it is inside of OpenStack, how it works, and kind of give you some overview there. Then I want to talk about Solidfire specifically, what Solidfire's advantages are in terms of OpenStack, what we can do, how we can integrate. And then I want to cover a little bit of usage inside of Cinder, how it works, how you use it from an admin perspective as well as from an end user's perspective. There's some really cool things I want to tie together between SwiftStack and Solidfire. So what we are is an all-flash array. We're designed for what we call the next generation data center, which is cloud. So when you say storage, especially in an OpenStack context, what exactly do you mean? There's a number of different types in OpenStack. You've got ephemeral, object, shared file systems, and block. And the way I kind of like to try and break it down is look at it this way. From an ephemeral perspective, that's the non-persistent. That's your VM when you boot it in a traditional fashion. Your instance comes up, you do your thing, you shut it down, it goes away, there's nothing persists, everything's gone. Usually it's using a file system or a QCal file, something along those lines with KVM. Objects, you guys just heard all about object store, so I'm not going to go into that too much more, but it's a great prequel to this. Shared file system, NFS, OpenStack is starting a Manila project to handle that specifically. I also like the idea of moving your shared file system stuff to object store because to me it's just a better model. But the point here is block is kind of the foundation for all of that. Block is what you build all these things on top of. It's your raw disk basically. So think of that as just your raw storage. That's where you need things like performance, high throughput, high change rate, stuff like that. So Cinder, the block storage project, we've got a mission statement. You can see here basically implement services and libraries to provide on-demand self-service to access block storage, right? These are kind of the official things that we float around. We put them on the wikis, we put them on the web page. The whole goal is to automate everything that you do with block storage using the Cinder project. In other words, when you're sitting there and you're setting up a new application or developing something, rather than go to IT and submit a ticket and wait for them to fulfill it and send it back, we're going to make it self-service. You're just going to go, you're going to get it, it's going to be on demand, you're not going to have to wait. On demand and self-service thing, that's two perspectives, right? That's not only from an end user that's actually just sitting there using it and doing test dev or deploying things or whatever, but it's also in terms of your automation. So the whole idea is you can automate the build up and tear down of all your different applications, all your different services. A lot of people aren't really sure about how Cinder actually is designed and how it's laid out or what it does and doesn't do. So I'm going to go ahead and I'm going to spend a little bit of time and I'm going to talk about this. It's actually a lot easier, I think, to understand this with pictures. So I've got a couple of diagrams I want to show. Basically, if you look here, what we have is this green blob that you see, this green background. That's the actual Cinder code base. That's the Cinder project. Okay. Inside of that, you've got all these different modules and components that run. You've got a REST API that's your interface to come in. And you have a scheduler, which is going to determine where requests go and how they're handled. One of the things that goes hand in hand with block storage is backups. So we implemented a backup service a while ago. The interesting part is when you get into this bottom port here where you have backup driver and volume driver. So the idea with Cinder is we give you a plugin architecture that doesn't necessarily implement your backend storage. You can use a reference implementation that we built on LVM. But we also give you the flexibility and the freedom to plug in different devices. So that's great if you're an existing IT shop that has storage and has things and you're redeploying or you're just trying out OpenStack or something like that. There's a good chance you can probably just go ahead and use some of the existing gear that you have. So as long as there's a driver inside of OpenStack and in the code base, you should be able to just plug it in and just use it. The idea is all of your automation, all of your tools, all of your workflow should be the same. Because all of the base API calls should be supported across every product that's inside of OpenStack Cinder. So one of the other misconceptions that people have in terms of OpenStack and how the storage works is they're under the impression that you spin up an instance and you make an iSCSI connection to your volume on the instance. And that's not how it works. So if you look here, what you see, what actually happens is you make an iSCSI connection to the compute node. So it does an iSCSI attached to the compute node itself, and then KVM does a VirtIO pass-through device into the instance. Okay, so there's a lot of reasons to do that. One of the biggest ones is just you don't want to have to deal with all the iSCSI networking and everything on your instance. And the other thing is this just automates everything. So the end user, the person that's consuming the storage, they don't have to know anything about iSCSI at all. And in fact, other protocols are supported as well. If I'm here, this is my compute node. I have a Nova set up and I have a compute node here. If I need to add another one, what I do is I bring in another 1U server or whatever it is that I have. I plug it in, I install the Nova software, and I point it to that Rabbit server. And that's it. That's how I add it. Rabbit's kind of a de facto. I mean, it's extremely robust. It's very reliable. It scales well. I don't have to take anything down. I don't have to change anything. I don't have to tell anybody that it's there. It's going to report into the Rabbit MQ server and get picked up, and everything's just going to pick it up and it's going to work. This particular layout that I have here, this is a single controller layout. If you do that, that controller will be your single point of failure. In production, we always recommend that people do dual controller HA, and then there's no single point of failure. I think that OpenStack can be as hard or as simple as you want it to be. It depends on how far you want to go with it. I think if you start small and think big, I think you'll have a much better time. But I think the hardest thing about OpenStack and deploying it and setting it up is figuring out what to use, what to build it on, because the choices are just amazing. So if you look at the Cinder project in particular, there's over 32 drivers that are supported in the OpenStack codebase right now for backends. Half of those you can probably just make a quick slice and you're not going to be interested. But there's a lot of thought that needs to go into that. And then you get into things like, what do I want my hardware to look like? What do I want my scale to look like? What do I want my network to look like? All those different things. And then throw on top of it all of the OpenStack projects and services. So there's a couple of dozen services now. But the key things to always ask, I think, TCO, so the total cost of ownership. It's really easy to say, hey, this is an open source free solution. All you need to do is buy some commodity hardware and throw it on there. But remember, you have to invest in architecting it, deploying it, maintaining it, supporting it, and everything else. You also have to think about that in terms of any product that you buy from a third-party vendor as well. So the thing about OpenStack you have to remember is it's very popular right now. So every marketing group, every sales group for every storage company in the world right now is trying to figure out how to sell into OpenStack. So what makes you a good fit? Things like scale, the architecture itself. Does it scale out? How large can it scale? Will it be able to stand up to the loads that you have in a cloud environment? The thing about a cloud environment, and when you throw in all this automation, you have to remember, is you're going to be doing things like making hundreds of API calls at the same time, maybe. Is your API on your device going to be able to sustain that? And a lot of them can't. There's, of course, support. Support's a big issue. Is somebody going to support this? When you call the support guy or gal and you're talking about my OpenStack setup is doing XYZ, are they going to even know how to spell OpenStack? Are they going to know what you're talking about? It's kind of a big deal. Performance and noisy neighbors is a big thing. Unfortunately, what they found out is, yeah, we can get all this great density on these VMs and everything for our compute side, but the problem is our storage devices can't keep up. And what happens is we have one person over here that's doing, thousands of SQL queries or something like that. In effect, what happens is the other person that has a volume on that same storage backend, they can't get any I/O. They can't get any throughput. Right? So that's a big problem. Third-party CI, activity in the community and stuff like that. I think that activity in the OpenStack community is key. OpenStack is very fast moving. It's got a lot of parts. It's got a lot of complexity and stuff like that. I don't think that anybody can truly say, hey, we have a device that's supported in OpenStack and works if they're not truly involved on a daily basis in the OpenStack community. Cinder can do some things like throttling at the hypervisor level. And then a lot of devices, including Solidfire, all do QoS. But they all do QoS differently. And some of them just do their own version of throttling. Some of them do their own versions of fencing and stuff like that. The thing about OpenStack is I always look at the bias is what the customers are actually using and deploying. And right now, the bulk of the customers are using and deploying KVM. But I think Docker is up and coming, and what we're going to see is more and more people that are doing both. I think there's a use case for both, and I think that's really important. We do things in a scale-out fashion, so you don't have to take things down, you don't have to scale up, you just add more nodes and let them report in, and off you go. So it's really similar and really analogous to how OpenStack works. These are kind of our 5 key elements in terms of the product, in terms of our design, in terms of what we keep going forward in our minds all the time when we're developing code, when we're developing new features for the product. Scale out being the first, as I mentioned, really similar to how OpenStack works. It's a model where you add nodes and you scale out that way. You don't take anything down. You don't have maintenance windows, things like that. Guaranteed performance. What we do is we actually set aside a pool of IOPS for the entire system. And when you create a volume, you get to allocate how many of those IOPS you want to go to that volume. So you can actually set a minimum as well as a maximum, and then we also have a thing called burst. You can guarantee that performance for each volume, and you can start delivering SLAs to your customers. Automated management. We started with the API and built everything off of it. Our web UI, our admin tool, everything that we have is built on the same API that everybody that buys a Solidfire cluster has access to. And you can automate everything that the cluster does. You don't need to have any special tools, any special UIs, anything like that. Everything is JSON RPC, easy peasy. High availability. We have no single point of failure. We do not use RAID, but what we do use is a better technology that we have patented called double helix. And the idea is what we do is we distribute blocks across the entire cluster. Let's say you're a new customer and you start out and you bought 5 nodes in this 9010 config. So you start out, you get 174 terabytes and 375,000 IOPS. 6 months down the road, things are going good. I want to move some more stuff to this. I want to get, I want it to be bigger. Add a node, that's it. It's constantly redistributing in the background. So you add a new node, add a drive, whatever, it redistributes. It redistributes the data and balances out, works really similar to like what Swift does. That also means things like, hey, I had a drive failure. No big deal. We've had customers that have drive failures. We have a report home capability. We call them and say, hey, drive's on its way. And they're said, what drive? They don't even realize that it failed because their performance isn't impacted. They don't have any downtime. Everything still works. You take that old drive out, put the new one in, cluster automatically rebalances, figures out where to put everything, off you go. No downtime, no hit. In theory, you could take an entire node. So you could take 10 drives all out and still run. The key is having 2 drives fail and both having the same block on them. So the idea is the more nodes you have and the larger you scale, the less probability of you having that. So one of the things I had mentioned, we can do min, max, and burst. One of the really cool things is this is completely independent of capacity. It's completely independent of size. A lot of vendors will play games with QoS, and the way you get a certain level of IOPS is by under provisioning the allocation, right? So if you need 1,000 IOPS, well, you need to have a 500 gig volume, and you can only use 30% of it. We don't do that. You actually get to allocate the entire volume. You get to use the whole thing, and we keep those 2 things completely independent. The other beauty of this is you can actually go in and modify it after the fact while you're running. So you can set it up here with 1,000, 11,000, et cetera, et cetera. You're running, you're going along, you decide you wanted to up it or you wanted to down it, whatever. You go in and adjust these sliders or send an API call in through our JSON RPC API and adjust those on the fly. No impact, doesn't hurt anything. Keep talking about the shared nothing and what we call helix. So right now, double helix, eventually triple helix. So the key to all of this is scale out, no downtime, failure resiliency, self-healing. A lot of people are under the impression that, oh, all I need is SSDs and I can be fast. Bad move. If you don't actually design your system to actually write to SSDs efficiently and correctly, you're going to wear them out. So we have specific algorithms and methods that we use in terms of how we write to the drives. You're still going to be rebalancing on the back, and you're still going to have those other NICs that you can go, that the SVIP's going to travel around, right? So depending on which one you connect to, it's going to vary, it's going to depend. Our QoS is completely done on the back end. It is completely internal in the software on the back end. We're not doing throttling or network controls or anything like that. We have our own way of writing to the disks. We're not sitting there and saying, hey, this is the disk that you're going to write to, et cetera, et cetera. So we have a pool of IOPS and we have an entire cluster of disks. So we'll actually get you better reliability and better numbers out of the non-enterprise class drives because of our software and how we work. We are truly designed from the ground up to use SSD. I always tell people that In our case, SSD is kind of a byproduct. It's really cool and it's awesome, but the idea for us wasn't, hey, we're going to use SSDs so we can jump on the SSD bandwagon and get the marketing. The idea is these are the things that we want our product to do and how we want it to work. The only way you can do that is with SSDs. So back to the question of drive failures, node failures, so on and so forth. I took out a node, everything rebalanced. I took out another node, it's going to rebalance again. So you can continue to do this. So the other key is when you talk about multiple drive failures and stuff like that, or multiple node failures, we had said, oh, you can't have two nodes fail. Well, that's true, you can't have two nodes fail at the same time. But if you have a node fail and you allow things to rebalance and you have that time, then you can lose another node. How long does it take? Is that what you're going to ask? Yeah, it depends. So there's going to be a threshold, right? You're going to get to a point where if you're truly 80% full or 90% full, do the math, depending on what your cluster size is and stuff like that, you may not have room to redistribute anymore. That could be a problem, yeah. And we'll give you alerts when you get to those thresholds. You'll get cluster full alerts and things like that. You know, everybody wants to talk, oh, you know, why can't I just use one or two nodes? Well, because the architecture and the scale and the availability and everything else, it's based on the principle of scale, right? So the more nodes you have, the more resilient you are. Regardless of whether it's Hadoop, whether it's Swift, you know, all these different things, they all have some things in common in terms of theory and philosophies and how they work, right? Because that's clustered technology. That's the whole point, is get away from single point of failure, RAID controllers, so on and so forth, and go to clusters. So eBay, PayPal, Internet, Brinkster, some of our early customers with OpenStack. You can see eBay, Mercado Libre. The whole point of the Solidfire piece is all solid state, guaranteed performance, complete automation capability, high availability, scale out architecture. You know, usually people associate SSDs with super high cost. You'd be surprised once you factor in effective capacities, compression, deduplication, stuff like that. Will come in much more closer to regular disk. One of the key things that I like to show off and that I'm really proud about is how easy it is to configure it and set it up. So all of the software, the drivers, everything that you need to run Solidfire and OpenStack is shipped and contributed into the OpenStack code base. It's all there. You don't need anything extra. You don't need any extra libraries. You don't need anything else. All you have to do is enable it in the configuration file. So there's basically 4 lines if you don't include the header. You just tell it, this is my driver. This is where the endpoint is. That's the SAN IP. And these are the credentials I want to use. And that's it. It's now configured. It's now added in. You can now use it. You create a QoS spec. You create that setting, give it a name, give it the values that you want, and you're done. There's your setting. So you create the QoS setting, then you create a volume type, and then you associate the QoS setting to that volume type. So now what happens is when a user goes in, and I went ahead and I switched to the dashboard to kind of show you this stuff is also in the dashboard for people that like GUIs. So an end user comes in, they'll say, I want to create a volume. I'm going to use that demo gold type that I created with those QoS settings, and I'm going to do 100 gig. Create volume, and off you go. The top is using the Cinder client shell, and actually just doing it that way. And then the bottom is actually, if you just want to write your own automation and have your own code, you can import the Cinder client libraries and do things directly that way as well. So everything's about automation. The last section that I wanted to talk about was the backups, right? And one of the things that we do is we do some things directly with Swift and SwiftStack to do what I call better together. You take 2 best-of-breed storage platforms. We're both built with the same principles in mind, distribution, availability, et cetera, both built on commodity hardware. But you put the 2 together and you've got some really compelling things that you can start doing. Cinder has a backup service. The way that backup service works, it takes your volume that you have and does an iSCSI attach to the Cinder node. And then it takes your object store backend endpoint and it reads the data off of the volume in chunks and sends it out to Swift. That's your backup strategy in Cinder right now. The value proposition, the beauty of Swift is the distribution model and how everything works and stuff like that. You can't do that with a Cinder volume, right? So the idea is, again, going back to the whole scale-out architecture, the nodes, geo distribution, everything else, right? And you don't get that by just saying, oh, here's a Cinder volume and boom, right? One of the things that we did with Solidfire is we actually integrated object store backups inside of our product, in our API. So we'll let you talk directly to Swift or Amazon or any S3 compatible for that matter. And we'll actually go ahead and use our same compression, deduplication, and everything else to actually go ahead and do a more efficient backup directly out to the Swift endpoint. Again, it's stateless, so if you run into an error, no big deal. You just pick up where you left off when things come back up. I think we're the only ones that do this. I don't know of anybody else that does this right now. So it's definitely a pretty cool feature, and it's one of those things that you put SwiftStack on the back end with Solidfire on the other side, and use that as your backup in your DR solution. It's pretty robust and pretty good way to go. Questions? How long did I go? No, it's not bad.
Are you using RAID 5 or 10 on the...
It is not RAID. We do not do RAID at all. It is a double helix, is what we call it. It is RAIDless. RAID means you have a single RAID controller. You have a single point of failure. Or maybe you have two, but that's either way, you have a bottleneck. RAIDs don't scale out. RAIDs scale up. We have numbers for other competing products that we go against. The SSD LVM solution inside of Cinder, the problem with doing that is you're going to burn through SSDs most likely. We do some things in Cinder that aren't really friendly to SSDs right now, particularly if you forget to do things like turn off secure delete and things like that. It's not going to be good. The problem with LVM is how do you scale it? You can start trying to do things like clustered LVM and DRBD and stuff like that. Unfortunately, those things usually all equate to a significant performance hit. They're also hard to manage because I've been working with them for a long time, and while they're great technologies and I'm a big fan, there's just a difference between using those and buying a product. We try and stay file system agnostic, especially in Cinder. We don't have anything to do with anything past the storage layer, right? The actual block layer. We don't put a file system on the storage at all. So we give you a raw volume and attach it to the instance, and then let you partition it and let you put a file system on it and do all the things that you want to do with it. That's completely up to the end user.
If I want to ZFS, do I see multiple disks? What would I see from the hardware side? I mean, do I see a big block?
So when you create a volume in Cinder and you attach it to an instance, what you see is a raw disk device. That's it. So you could take 10 of those or 20 of those and put ZFS on it and do something like that. Sure.
How do you manage that accessing to the cluster? Do you have like do you require a load balancer, or do you have something built into it to manage that?
So we do a virtual IP, so it's going to float. And what's going to happen is that endpoint could end up being on any one of those nodes. Yep. So we have a cluster master that's going to float around. So the Solidfire cluster right now is not geographically dispersed. That's a Swift thing. One of the things I didn't really talk about was replication. So in the model, kind of like what you're saying, what I would do is I would have a cluster in one data center and a cluster in another, and I would set up replication between the two, and I would replicate that way. Okay, 10x.